So welcome everybody. This is 15.3 on triangle inequality. Um, I want to do a little experiment with you guys. Okay. So you guys see this ruler. I'm gonna start at 1 or at 0 and make this one 2 inches long. This side, I'm gonna make this side 3 inches long. Okay. So I got one side at 2. I got one side at 3 inches. And then another side, I am going to draw out 5 inches. Okay. So my question to you, or let's make this a different color. My question to you is, with these 3 segments, can I make a triangle? You guys say yes, we can. I moved my sides a little bit down so I can play with them. Now here, I'm gonna try it. Okay. I'm trying my best not to move it either. Is that a triangle? But look at this part. This part here. Yeah, that's why it's not a triangle. Okay, I should be more specific. Can I make a perfect triangle then? No, right? So with a 2 inch side, a 3 inch side, and a 5 inch side, I cannot make a triangle. The best I can do is try to make a triangle and try to make this side like really thin, right? But still, there's a little space right here that doesn't allow me to make the full triangle, right? To connect the two sides together. So my instinct tells me, okay, if that doesn't work, then I'm going to try and make this even closer. Make this a little closer, right? But still, there's a space right here, right? It's smaller. Yeah, as you can see, it's smaller, but there's still a space, right? So my instinct, tells me to try to get it even a little closer. But still, there's a space. You guys see that? And it's a really thin triangle now. Now, the endpoints of it are all lined up together, right? But this little part just doesn't want to come together. The only way that it comes together is if it's the same segment. That makes sense? Yeah, because if you think about it, 2 inch and 3 inch, 2 plus 3 is 5, right? And if my third side is this equal to the same length of the sum of any other two sides, right? The best thing I could do is just make it the same segment, right? So I need the sum of any two sides of a triangle to be greater than the third side to make that little space for the triangle. That makes sense? Yeah. And that's the triangle inequality theorem. Okay. The triangle inequality theorem states that the triangle, oops, inequality states that the sum of any two sides of a triangle must be greater than the third. Okay. All right. So if I have triangle here, and if I label this triangle ABC, side AB plus side BC must be greater than side AC. Side AB plus side AC must be greater than side BC. Side AC plus side BC must be greater than side AB. That makes sense? Yeah, the sum of any two sides must be greater than the third to make that little puff. Yeah, to make that little space to make a triangle. Okay. So using that, an example here, and these side lengths make a triangle? Yes or no? 1, 4, 8, and 10, and 2, 7, 9, and 18. I'll give you 2 minutes. Figure these out. Okay, can we make a triangle with number 1, 4 feet, 8 feet, and 10 feet? Yes. The way you check it, make sure make sure that the sum of the two smaller sides is greater than the biggest side. That's all you got to check, right? So 4 plus 8 is 12. 12 is greater than 10, so that's my check. Okay? If you check the other two, you can. But of course, if you use a bigger side and you add more to it, it's going to be smaller or it's going to be greater than that third side. Okay? So if I check for number 2, 7 plus 9, is that greater than 18? But it must be, right? 16 is greater than 18. Since that's false, it's a no. Okay? That's it. Questions? No? Simple? Going back to my ruler here, another activity. I'm going to have a, you know what? I'm going to have a 2-inch. Okay. And let's make it a little bit bigger. Make that 31 degrees. Okay. Make this side 3 inches. Okay, so I have a 31 degrees. And a 3-incher, right? Okay. For this next one, I'm going to have a 2. I want to make this. Let's make this 115. I want to make this 3. Okay. Do we all agree that it's 2 and 3? 2-inch, 115 degrees, and 3 inches, right? So the side lengths are the same, correct? Now what we're comparing here in this activity is the side that's connecting, that makes the 2 triangles, okay? I made them really exact on purpose, okay? Let's first talk about the difference. What's the difference between the 2 triangles, specifically in blue and in purple? We have the 2 same sides, 2-inch, 2-inch, 3-inch, 3-inch. Emily? Wider, longer. It's longer. Which one's longer? The blue one, right? So we all can see that this one here is longer than this guy here, right? And there's another theorem here. If you think about the long side, it's across from the 115 degrees, right? This 31 degrees, the small side, is across from the 31 degrees, correct? Yeah. So this tells me that here comes another theorem. The side, I should say, opposite the larger angle is greater. Okay? And vice versa. The angle opposite the larger side is greater. Okay? So if I know the relationships between the angles, the angle measures, and the side measures, I know the relationship to the side measures or the angle measures. Okay? For example, if I have this, let's say, this triangle here. I say that that's 8 inches, 13 inches, and 17 inches. That can make a triangle, correct? Okay, because the sum of any two sides are greater than the third. And I'm going to go A, B, C. Since I know 8 is less than 13 is less than 17, right? From least to greatest, I can order the angle measures as well. So since 8 is opposite angle C is the smallest angle. The biggest angle is going to be opposite the 17 because that's the biggest side. Angle B is going to be here. And then angle A is in between them. Yeah. And vice versa. Okay. So if I say, if I have this triangle here, and I say this is 100 degrees, A, B, C. And I say this was, let's say 50 degrees. So this has to be 30 degrees, right? 180. Yeah. So since 30 degrees is the smallest side, then 50 degrees, then 100 degrees, the side opposite these angles have that same relationship. Okay? I ordered the angles in terms of least to greatest. Angle C is the smallest, then angle A, then angle B, right? Yeah. So the side opposite those have that same relationship. So I can say AB is the smallest side, then it goes BC, then it goes AC. Cool? Yeah. All right. And that is your lesson for today, class. Okay, these two big ideas are your lesson for today. All right, and that was the triangle inequality 15.3. Thank you.